This is Physics 1060, Descriptive Astronomy. In this first lecture, we're going to discuss Chapter 1 in this course. For most of you, the goal is to satisfy the science requirement. My goal is that you understand what science is, and astronomy is going to be a means to this end. So what's out there, and where is it? We're going to learn about the main different kinds of objects in the universe, such as stars, of which the Sun is one, or planets, just as Earth and Jupiter, which are small objects that orbit the stars, or galaxies, which are vast collections of stars, our own galaxies, the Milky Way, or other novel things that we might not have seen before or heard of before, like black holes or neutron stars or pulsars. We're going to talk about how things work and why things happen. Why does the sun shine? How do satellites stay in orbit? How stars are born? And why exploding stars make things like black holes. We'll talk about how do we know these things. So we need to understand things like telescopes, spacecraft, light spectra, how to measure, say, distances to different stars, or how do we measure the age of the moon. And how sure are we that we're right? A major misconception about science is that science is a series of solved puzzles. In fact, there's a graduation of certainty within any science, and these levels of certainty change as new observations are made and new theories are formed. If I was teaching you physics, I would have a difficult time getting this idea across, because most everything that you typically learn in an elementary physics class is very well-established physical laws. In the astronomy class, however, we're going to meet ideas with a wide range of uncertainty. For example, there's going to be things that we're not going to think twice about. The sun will rise tomorrow. Things that all astronomers would bet their careers on. Earth moves around the sun. Normal matter is made up of 92 natural elements. There are also things astronomers are confident about, but we could cope with the change. Jupiter is made mostly of hydrogen. The nearest star is about 4 light years away. We're fairly confident of these things, but we could cope with a change. There's some that have a lot of room for discussion among astronomers. How are planets formed? Will the universe continue to expand forever? And things that there are lots of doubt. We have really no idea. Is there life elsewhere in the universe? Now, there are some topics we're really only going to look at very lightly. Things like star names and constellations. That's something that maybe if you went into amateur astronomy and were out looking at stars with your own personal telescope, you would need to know. That's not really what's important here. We really want to look at the science here. Things like navigation from the stars or astrology. We'll talk about those briefly, but those are not things that are going to be dealt with in this science class. Now, before we begin with any more science, what we first need to consider is in the beginning. This is a science class at a Christian university, and we often get asked things like, what about Genesis? So I'm going to base a lot of the things I'm going to talk about here on a book called Genesis, Basic Principles by James Boyce. And he has certain points that he likes to make. First, this is the first great matter in the Bible. The one related most to our origins is God. He has no beginnings at all. He's the first subject mentioned. In the beginning, God created the heavens and the earth. Genesis really tells us about the origins of man, that God created us. And without his divine revelation, we would be led to think that maybe we spontaneously came into being. Genesis gives us the origins of the human family. Genesis tells us of the origins of evil and that mankind is a product of our own choices. Genesis tells us that we can do nothing, that God can do anything. The origins of our salvation are in Genesis, and man is justified by faith. Genesis shows us God's love and divine initiative. Adam, Eve, and Abraham didn't seek God, God sought them. Genesis tells us of God's divine judgment and how he dealt with the fallen Adam and Eve. Genesis is not a scientific description of the details of how God created things. The importance of Genesis is the who of creation and how he deals with man, and not the how of creation. So let's look at the 5 popular views of creation. And as Boyce says, let's say at the beginning that the final answer to how the universe and all that it is in it came to being may not be attainable right now. The first view is atheistic evolution. There appears to be natural variations through mutations within species. And atheistic evolution talks about overpopulation. In most cases, more individuals are born to a species than can possibly survive. So there's this struggle for existence. In order to survive, individuals must compete for resources. It brings us to this idea of the survival of the fittest. In a competitive environment, only those individuals best fitted to survive do survive. There's an inheritance of favorable characteristics. Fit individuals pass on good characteristics to their descendants, and new species arise. By continual survival and reproduction, new species are produced and the process continues. Some of the evidence and problems of atheistic evolution. The fossil record shows variation of species, but it's not finely graded or continuous. There really hasn't been enough time for the species change that is given in atheistic evolution. Mutations do take place within a species, but there's no evidence that show that mutations have caused different species. The theory needs an old Earth and an old universe. The theory does not explain the origin of matter, only how things on the Earth have changed. There's something called the law of entropy. The law of entropy is a law of thermodynamics which basically states that things go from an ordered state to a disordered state. And so, going from, say, simple-celled organisms to, say, a human being, really goes against the law of entropy. And really, there's this emergency of life. Atoms becoming amino acids, and amino acids going to proteins, and proteins to cells, and things like the personality of man. Why we're so altruistic. The second theory is theistic evolution. This theory proposed by persons who say there is a God and he used evolution to create life on Earth. That God provided the energy and direction of the process of evolution. And Boyce says the first thing we should say is that at least is a possibility. God could use any method and means he wills to use. There's some biblical possibilities to theistic evolution. The word let in Hebrew, heya, allows for the development of existing material. The word create, bara, in Hebrew, is to create out of nothing existing. So evolution was God-directed. At specific times, God intervened and gave direction to the development of the universe. Well, this has some problems too. Generally, evolution does not include continuous direction or intervention. The fossil record is incomplete and inconclusive. And to get from things like humanoids to Adam is a problem, and the theory needs an old Earth and an old universe. The next is called the gap theory. This theory states that there exists a very large period of time, measured in billions of years, between Genesis 1:1 and Genesis 1:2. Genesis 1:1 tells us that God created out of nothing matter which evolved into the universe. And Genesis 1:2 then begins to tell us how God entered back into creation to develop the earth and all living things. The problem with this is the theory interprets the 6 days of Genesis to be long geological periods. And say in Exodus 20:11, for in 6 days God, bara, created the heavens and the earth. There's the problem of death before God's judgment. There's a record of death in the fossils, and so the theory needs an old earth and an old universe. The next is 6-day creationism. It views Genesis as 6 literal days and points to a young earth, say 6 to 14,000 years old. I believe that all fossil records were created by the flood. There's a lot of strong proponents for this theory. There's a Creation Research Institute in San Diego, California, based at Christian Heritage College, and it's led by Dr. Duane Gish, who's a Christian biologist. And there was a very interesting debate between Dr. Gish and Dr. Hugh Ross, who's a Christian physicist and astronomer and doesn't follow a six-day creationism theory. It used to be found on Jane Dobson's webpage. I'm not sure if it can be found there still, but do a little search on the internet and you'll probably be able to find it. So the problems with six-day creationism are the six-day creation of Adam. The fall of man and death and the flood have to be literally interpreted. And quite frankly, the facts of the sciences of geology are very difficult to harmonize with the flood. And the entire theory hinges on the Hebrew word yom, or day. Creationists might say that it can only mean a 24-hour period. However, in other Old Testament passages, it's used to describe an age, not just a day. Fossils take a long period of time to form, much more than just thousands of years. And looking at the age of the Earth and other objects in our solar system, as dated by rocks and uranium radioactive dating, is much older than the 6 to 14,000 years in the six-day creationism. The last is progressive creationism, also known more recently as intelligent design. And this theory attempts to show how the theories of the origins of the universe, understood by science, match the revelations of Genesis. Although it's not a new theory, it's really gained recent renewal with this whole ID movement. The theory states that Genesis gives a clear description of who created all things and not of how God did it. And it seeks to understand new scientific discoveries in light of the revelation of Genesis. Considers 6 days of Genesis as very long geological periods. Some problems with that is new scientific discoveries are not easily matched with the Genesis account of creation. The fossil record and the order in which plants, fish, and land animals appeared in Genesis do not match the geologic record. The Genesis day and the introduction of death at the fall are difficult to match with scientific records. So I'm not going to tell you which of these five I prescribe to. At the end of the class, given time, I'll give you a detailed position of my view. But what I want us to do is first examine the scientific information that science has learned about the universe. And it's important to remember this. Your view of the details of creation don't determine your salvation. There are many strong Christians who believe in literal six-day creation. There's a lot of strong Christians who believe in creation took billions of years and have a very old earth. The scriptures really say, believe in the Lord Jesus Christ and you shall be saved. It does not say in any place that we have to have a certain theory of creation. I want you to take some time to talk about your view of creation in the discussion boards. This doesn't have to be too in-depth, but which of those five theories do you most identify with? And maybe a statement or two of why. Now, this is descriptive astronomy, which means we're not going to be doing a lot of math. However, we have to talk about a little math, because there's a definite need for quantitative measurements in astronomy. We can't just say, these things are big and these are bigger. So I expect you to know the sizes of a few objects, and I expect you to be familiar with the length units of the metric system, which is used throughout astronomy and in almost every country in the world. The most important units are those for length. A kilometer is about 5/8 of a mile. A meter is a few inches over a yard. A centimeter is about 0.4 inches. And a millimeter is 1/10 of a centimeter. You should be familiar with the powers of 10 notation, called scientific notation. We'll go through some of that real quickly, which is necessary in astronomy to avoid spending all of your time writing and counting zeros. So, before we go anywhere, we're going to talk a little bit about scientific notation. We use it to be able to discuss large and small numbers. For example, the distance to the Sun is about 150 billion meters, which is written as 1.5 times 10 to the 11th meters. Or the time from turning on a light switch from when the light turns on is about 0.000000001 seconds, or 1 times 10 to the minus 9 seconds. We can also use prefixes to indicate powers of 10. So for example, a kilometer is 1,000 meters. A nanosecond is 10 to the minus 9 seconds. So here I've given you a list of the prefixes. You don't need to have all of these memorized. You should really know from 10 to the plus 9 to 10 to the minus 9, just because those are more commonly used. But you can see there's lots of different symbols. And quite frankly, we're going to be talking about things that are maybe yotometers away from us, or things that are femtometers in size. And so astronomy is really going to cover all this, and really getting an idea of how all these powers of 10 work is a difficult thing to describe. So what I've given you is a video called Powers of 10. And it's an older video, but it really gives you a good idea of all the different powers of 10 and the large and small of our universe. So let's look at some powers of 10 and changing numbers to scientific notation. 345,000. The decimal point's right here. I'm going to move it over 1, 2, 3, 4, 5 places. So I get 3.45 times 10 to the 5th. Or 6,700. I move the decimal over 1, 2, 3 times. So it's 6.7 times 10 to the 3rd. Or 98,600,000,000. I move over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 9.86 times 10 to the 10th. We can go the other way. 0.025. In this case, I'm moving the decimal the other way. 1, 2 positions. So it's going to be 2.5 times 10 to the minus 2. The minus means I'm moving the decimal that direction. Or 0.66700 is going to be 6.77 times 10 to the minus 1. I'm moving the decimal point only over 1. Or 0.000000986, I'm going to be moving it 1, 2, 3, 4, 5, 6, 7. So 9.86 times 10 to the minus 7. Now another unit of distance besides the meter that we might use is something called the light year. Light travels about 3 times 10 to the 8th meters every second, or 186,000 miles every second. That's about 7 times around the world at the equator in 1 second. So a light year is a distance that light can travel in 1 year. We can figure out how that is. We take 3 times 10 to the 8th meters per second. We say, well, there's 60 seconds in a minute. There's 60 minutes in 1 hour. There's 24 hours in 1 day. There's 365.25 days in 1 year. And that's going to give us, if we multiply these out, notice that the seconds go away, the minutes go away, the hours go away, like algebraic things, the days go away. I get meters per year. And I multiply by 1 year, and I get then that a light year is 9.5 times 10 to the 15th meters. The above example that we just looked at is an example of converting units. Astronomers have a large sense of time also. So for example, the Earth revolves around itself once per day. The Moon revolves around the Earth in 1 month. The Earth revolves around the Sun in 1 year. The Sun revolves around the galaxy in a galactic year, which is 250 million years. Our galaxy orbits other galaxies, which we'll get to later in the class. But we can't even measure yet how long that takes. So converting units is changing from one unit to another, such as going from miles to kilometers, or hours to seconds, pounds to kilograms, miles per hour to meters per second. And it's all done by multiplying by appropriate values of 1. I can multiply anything by 1 and it doesn't change it. So if I know, for example, that 1 inch is equal to 2.54 centimeters, or 1 inch is equal to 2.54 centimeters. So I divide both sides. I get 1 inch over 2.54 centimeters is equal to 1. I can multiply this value by anything and it's not going to change it. And I can use that to change units. So for example, if I wanted to convert 6 feet to meters, so I start with 6 feet. I'm going to multiply by a 1. Well, I know there's 12 inches in 1 foot. And I know that there are 2.54 centimeters in 1 inch. And I know that there is 1 meter in 100 centimeters. So now I can cancel out algebraic units like algebra. So for example, there's a foot on the bottom, foot on top, inch on the bottom, inch on the top, centimeter on the bottom, centimeter on top, and I end up with meters. So it's 6 times 12 times 2.54 divided by 100, and that's going to be 1.83 meters. So 6 feet is equal to 1.83 meters. Or I can convert 180 pounds into kilograms. So 180 pounds, and I know that there is 1 kilogram is 2.21 pounds. So the pounds cancel out, and I end up with 81.8 kilograms. So that's all the math that we're going to do in this course. I might ask you one question on the exam, maximum. Don't stress out about the math. I more want you to understand the concepts of the science that we're going to be talking about and the concepts of astronomy. So that's the end of Chapter 1.